Good morning, and welcome to the Innovator Pitch Competition as part of today's summit. My name is Mikkel Brack, and I'm very excited to moderate this session today. My company, Urban Living Futures, has a great interest in discovering and supporting the scale-up of best-in-class urban innovators, such as the ones that you will hear from today. We organize this through our digital platform, Uplift, which is an innovation marketplace with deep information on emerging innovations, including the performance measurement and verification, progress tracking, geospatial context, and the feature to allow experts to review and assess and select innovations for such purposes as this event today. And that's how we came up with this superb selection of innovators that will be pitching to our panel of judges. We are thrilled to partner with the IoT PropTech Summit for the Innovator Pitch Competition. And this is a great forum for the selected innovators to present their ideas to executives in some of the leading brands and companies in the industry. Over the last few weeks, we have received applications from some incredible SMEs doing truly innovative work. And after a lot of hard thinking and some tough decisions, our expert assessment panel narrowed down the applications to 3 SMEs with novel and very relevant technologies. These innovators will present their ideas to our panel of judges today and participate in a round of Q&A following their presentations. And we will announce the winner of the pitch competition by the end of the event today, at the end of the conference. And the winner will receive the honor of being named the 2020 IoT PropTech Summit Innovator of the Year, as well as support from and meetings with some of our judges, and a 1-hour consultation with Microsoft One commercial partner team or a Microsoft IoT business leader, as well as coaching for Microsoft AI and IoT Insider Labs. So let's begin the pitch competition by introducing our wonderful panel of judges. These are people with deep knowledge of IoT and PropTech, and they could be very strategic and instrumental contacts for the innovators that are pitching today. We have with us today Adrian Wang, who is the Director of Innovation and Sustainability at Tridel. Charles Dyer, who's the CEO and co-founder of Sovereign Asset Management and the CEO and co-founder of Trivertis Capital. Julie Morin, who is the Director of IoT Solutions, Smart Infrastructure at Microsoft Canada. Mark Bryant, who is the Chief Information Officer at PCL Construction. And Travis Allen, who's the President and CEO of TWIA Investment Holdings and CEO and President of Eddy Solutions. So judges, thank you all for being here. And I'm sure you're all very excited to watch the pitches, although you also have the tough job of selecting over the next few hours one winner from this excellent selection of teams and products that you will hear about in the pitch competition. So today's participating innovators include Argentum Electronics with their product Spacer, which is an intelligent direct current microgrid, Sky Foundry with Sky Spark, a building analytics platform, and Innova Corporation with their smart geothermal piles. Each innovator will give a 5-minute presentation, after which we will have a 5-minute question and answer period with the judges. And we'll be providing some nudges, but please, innovators, be mindful of the time and stick to your 5 minutes. And I'll try to keep the question and answer period to 5 minutes as well. And just before we start the presentations, I would like to mention that this webinar will be recorded, allowing people who cannot join at this time to view it later. So our first presenter today is the team from Argentum Electronics. We have Bolis Ibrahim and Sagar Jaiswal with their innovation Spacer. Argentum team, the floor is yours for the next 5 minutes.
Well, thanks. Just want to make sure everyone can hear me okay. Right on. Cool. I will share my screen and I'll set a 5-minute timer. Awesome. You can see that?
Yes, we can.
Full screen. Perfect. Okay. Hey everyone, my name is Bolas Ibrahim. I'm the co-founder and CEO at Argentum, and I'm joined today by Saga Jaiswal, who is also co-founder and CTO at Argentum. And we're on a mission to change the way we distribute electricity in buildings from alternating current to direct current, and we do this using a patented approach. The reason this mission is important to us is because it decarbonizes our planet by saving buildings up to 40% in electricity costs from a baseline with alternating current. So the problem we're really tackling is a century-old problem. About 140 years ago, Thomas Edison and Nikola Tesla, they were disputing how electricity would be sent across the country. So we actually think that Edison had a good idea, but that was well ahead of his time. So he didn't have really the technology to distribute direct current power, but we do today. And because we went with Tesla's concept of alternating current, what we do today is we convert all of that alternating current back to direct current, because everything in front of you is DC and digital. All of the computers you're using, the screens, the televisions, the speaker systems, the printers, the cell phone chargers, the laptop chargers, everything is DC and digital. Even the appliances, modern appliances. LED lighting is a DC device, and most modern HVAC systems use brushless DC motors. If we think about the price that we pay for using alternating current, we can look at it like this. We waste up to 22% power in converting for LED lighting systems, up to 34% in USB powered devices. And that's actually the reason why your USBs get hot, the USB chargers and your laptop chargers. The solution we've come up with for this problem is a patented plug and play modular DC power distribution system that's really easy to install and distributes DC power very efficiently for LED lighting and HVAC systems. And it's augmented with sensors to make everything more intelligent, and a building automation software or digital twin. The system is actually really easy to install. It's a routine installation for any electrical installer. And typically what they do is go to the AC distribution panel. That's the breaker box or the fuse box where power is distributed into your building or into your home or into your commercial property. And they would install a DC sub panel next to it, which can be thought of like a very large cell phone charger. And then they would, with Ethernet cables, so this is a power over Ethernet system, although it's wire agnostic, we like power over Ethernet, they would plug it into these nodes. So this is a model of a node that can be daisy chained. So a bunch of Ethernet ports that can be daisy chained. They can plug into anything from light fixtures to HVAC units to motorized roller shades and to third-party keyless entry systems. And it automatically recognizes what it's plugged into. And once sensors are installed, everything becomes automated. So there's two major sources of energy savings here. It's the automation and the DC power distribution. So because we eliminate the need for converting from AC to DC at the point of load, we're able to save up to 20% and then another 20% from a baseline with no automation using sensors. This is a model that we're working on for how this DC sub panel might look like. Today it's like a standard, actually like a standard electrical panel, but we're trying to make it look like really sexy. The markets that we play in, so we like the building automation market. It allows us to provide a lot of recurring value and actually capture a lot of recurring value for ourselves. We have a very good solution for bringing building automation into the cloud. We also like the prefab and modular construction market. Because our system is modular in its nature, it fits very well with modular construction. And I think Ontario is like a leader in the modular construction space. So we've been working very closely with some of the leaders in the space. The business model we take is two approaches. So we start off with an enterprise sale and then follow it up with a lot of recurring services that we can provide to our clients. Everything from security and access control to building automation and sensors as a service, facilities management, and operations management. This is our team. So I'm sure, so Saga's here. Saga, we have like 20 seconds. Maybe introduce yourself in 10.
Yeah, I'm CTO and co-founder of Argentum. I have a background in mechanical engineering, electrical, and software. I help Bolas lead the hardware, and I also lead the software team here at Argentum.
Awesome. Yeah. So we have a lot of expertise in project management, specifically in electrical contracting. I spent most of my career in electrical contracting. It's actually a family business. And hardware development, we've dabbled in previous startups, and we're very well versed in the full stack of the web dev. And yeah, thank you for listening, and I hope that you'll join us on our journey of creating a future with smarter buildings that serve the people inside of them and the environments around them. Thank you.
Wonderful, thank you. And you can keep your presentation on the screen while we have a 5-minute question and answer period with the judges. Please go ahead, judges, and ask any questions that you have. Feel free to jump in. Who wants to go first?
Hey, Bolas, Mark from PCL Construction here. Thanks for the presentation. One of the things that you mentioned in your cost saving paradigm was automation. It wasn't clear to me what the automation component was from a savings perspective. I understood your power conversion AC to DC, but I didn't understand the automation component. Just some more color on that if you could. Thanks.
Got you. So because we're delivering power to these devices, and one of the philosophies of our design is to make every device a smart device. So every one of these drivers that plugs into like the HVAC or the lighting has the ability for us to control it. So if we have the ability to control it, we want to automate it. So we have two simple sensors. So there's your standard occupancy sensor that will just tell us if people are in the space and help us understand how to better automate the lighting in HVAC. So turn off the lights when no one's there. And now a more sophisticated indoor environmental quality or IEQ sensor that helps us understand everything from the temperature, the air quality, the humidity levels, helps us automate the ventilation, like how much air to ventilate into the space. It also helps us automate the lighting for daylight harvesting. So we understand the light levels inside the space. And if the sun's out, we want to dim the lights because as the human eye won't perceive the brightness of the lights. So we have a lot of different cues that we take from, a lot of them from LEED, from the like LEED. We take a lot of those automation cues and sort of build them into the system. Does that answer? Is that like what you were looking for? Yeah, okay, cool.
Yeah, I got a bunch of follow-on questions, but I don't want to hog it. I'll let some others ask some questions.
So I have a question around the target market. So if you can go back to the target market slide. So you highlighted some of the target market as property owners in the AEC industry, but have you thought about targeting the actual utilities industry?
Potentially, that's actually like one that we'd like to target. It would require us to move further downstream towards the meter. Like the more downstream towards the utility meter we move, the more we can interact with them. And actually, like I really like this because the utilities want more information about how energy is being used in the building. So we do want to collaborate with them. So we do see that as like a future potential market.
Great, thank you.
So Charles Dyer here at Trivertis. So this does not negate the need for wiring a house. So if I was building a new house, I still need to wire the entire house. This is sort of a sub panel for certain certain appliances, certain outlets, certain things I'm using, the lighting system and whatnot.
Yes, this would not replace everything. So you would still have AC outlets in a house, depending on how the house is designed. For like the foreseeable future, maybe like the next 5 to 10 years, this is like a side-by-side system. And then maybe in the next 20 years, it's a purely DC-based system because we have less and less need for AC in the home or in the building.
So not being an electrical engineer, how many of the appliances, like, can you explain a little bit? It seems to me that this would be a very small amount of the energy consumption of a typical house. Is that correct? Like what percentage with your product today, what percentage of the energy consumption would run through this device?
It's about 80% of the electricity consumption because the energy in the home is majority of it's lighting and pushing air throughout the home. But actually heating and cooling the home, most of that's done not electrically, it's done through gas or through other means. But the use of electricity is mostly used by direct current devices because LED lighting is a big push of this. So LED lighting is like rather recent. And then brushless DC motors for HVAC are more efficient. So the more we move into the future, the higher that percentage will go until it reaches 100. And if you think about solar and energy storage, these are all DC or direct current devices. So yeah, valid question. It's an interesting question, but surprising answer.
Yeah, actually on that note, it's Adrian here from Treadell. We actually looked at this as well for one of our developments to understand the implication of DC and how this would rewire buildings. We really struggle with finding appliances on the heating side. So on higher wattage equipment like ovens or microwaves or cooktops, for example, or even AC plugs for hair dryers, we couldn't find those appliances that would run off a purely DC application. And so we ran into those challenges. And I think you touched on this earlier, saying that you needed to run wires in parallel effectively. You would have a DC grid as well as an AC grid within a home.
Yeah, so this is like, so sorry, go ahead, sorry.
Yeah, so that's one of the challenges that I see. The other challenge that we encountered was to understand how far upstream, and I think you alluded to this earlier, do you want to install that DC device, right? And in a high-rise building, our voltages are fundamentally very different. We have a three-phase system. You know, we're using 208 volts and 120 or 600 and 347. Do you have any applications for a high-rise commercial sector? Have you considered those points?
Of course. So like like DC is a superior way to transmit electricity, right?
Mm-hmm.
Because you can go very high voltage without having the same safety concerns as AC. Because in AC, the insulator has to be like quite large for higher voltages, but for DC, it's not the same case. So it is like a superior way to transmit electricity. And the reason I want, like I say, it's like it makes sense to push it back further to utilities, is because even the utilities are starting to transmit DC over long distances more and more. In Canada, in Western Canada, we have a HVDC line, a high voltage DC line that transmits electricity from the south to the north. It's really like the way of the future. And when you think of appliances, you can actually look. There's a building, a hotel, the Sinclair Marriott in Texas, which is a phenomenal use case, like case study for this, where LG designed appliances for that building to be purely DC. So refrigerators, ovens, they designed appliances because fundamentally like a heating element is a resistive heating element. It works AC or DC. It doesn't matter what electricity gets. This is all like legacy stuff we're stuck with from the days of Tesla, like the way infrastructure was built and why it's hard to change infrastructure.
So sorry to cut off. This is a great conversation and all very interesting. And I'm sure the judges would love to hear more, but we're over 5 minutes for the question and answer period, and we're going to have to move on to the next presentation. So thank you very much.
Thank you, everyone.
Please stop sharing your screen. Right. Okay. So that was wonderful. Thank you very much to the Argentum team. Next, we're going to hear from from Innovator with their geothermal piles. So do we have Andrew Lee is available? Yes. And
yes.
Share your screen and you can begin your presentation. Thank you.
Okay. Can you see my screen and is the audio okay?
Yes, very good. Thank you.
Great. Good afternoon, everyone. I'm Andrew Lee, president and co-founder of Innovator GeoCorp. And I'm here today to tell you about how we're innovating heating and cooling from the ground up. So if we look back at our past, did you ever wonder why our ancestors lived in caves? Sure, safety and security are certainly reasons, but another important reason is the stable temperature of the ground and its ability to moderate the outdoor climate. So in the wintertime, the caves were warmer than outside, and in the summertime, they were cooler. But as we developed and we emerged from our caves, we built homes, buildings, and cities. All the while, this meant more and more energy just to keep our fragile bodies comfortable. And so here we stand today in Canada, where nearly 80% of energy we use in our buildings and homes is just for heating and cooling. And this represents nearly a quarter of all the energy we use in the country and produces nearly a quarter of all the carbon emissions in the country as well. But there is a renewable solution out there, and it takes a cue from our ancient ancestors, and that's geothermal heating and cooling, which uses the stable temperature of the ground to heat and cool a building. So geothermal uses the same process that your air conditioner uses to cool your home by moving heat from your home to the outside air. Except with geothermal, the heat is moved into the ground, which is at a much more stable temperature. And the process is reversible, so you can provide both heating and cooling. And because we're moving heat and not burning a fuel, geothermal is incredibly efficient and has zero direct emissions. So for every 1 unit of electricity needed to run a geothermal system, you typically move 3 to 5 units of usable heating or cooling energy into a building. So if geothermal systems are so efficient, then why are they not more widely used? Why do less than 0.1% of the buildings in Canada use geothermal? Well, like many things in the world, it all comes down to cost. And unfortunately, geothermal systems have a high upfront cost using conventional installation methods. So in conventional systems, heat is transferred into the ground by circulating a fluid in plastic pipes that are typically drilled and installed 300 to 600 feet deep. So as you can imagine, installing these pipes is not cheap. So the payback for conventional systems can oftentimes be more than 10 years. While for some that might be okay, for most owners and developers, that's just not good enough. Our solution is to make use of the infrastructure already going into the ground by integrating geothermal functionality directly into steel foundation piles. This way you can get both the foundation of your building and your geothermal system together in one. In doing so, our aim is to drastically cut the cost of implementing a geothermal system so that the payback can be less than 5 years. It's a very exciting time right now because at this exact moment, we're knee-deep with installing a full-scale test project in the city of Waterloo at a facility owned and operated by Waterloo North Hydro. In fact, the pictures shown here were taken just last week. The project is supported by a grant we received from the IESO Grid Innovation Fund. And with the help of our implementation partners, we're going to have the system up and running in the next couple of weeks. Our revenue model is to start by offering the design and installation of geothermal pile systems on a fee-for-service basis. With our test project, we're also going to be developing control software that utilizes some unique thermal storage properties of the geothermal piles, which may offer a means to continuously optimize the performance of a system. This lends itself more to a subscription-based operation service. And I'd be happy to talk more about these unique thermal storage properties and the potential control strategies during the Q&A. We're a team of passionate professionals with deep experience in renewable energy, construction, and engineering. And we're also collaborating with a research team from Ryerson University, which is recognized globally for their research in geothermal systems. Our team is dedicated to unlocking the answer beneath our feet and finally change how we heat and cool our buildings. Thank you, and I'm happy to answer any questions you might have.
That's wonderful. Thank you, Andrew. Great pitch. And now for a 5-minute question and answer period with the judges. Who wants to go first?
I can jump in on this one. This is Travis from Eddy Solutions. Great job on that presentation, by the way. That was super concise and very informative. Appreciate that. Can you just at a high level tell me, you know, in the kind of traditional model where the payback is 10 years and in your model where it's 5 years, can you speak to the efficacy of the two systems in comparison to each other and maybe outline some of the key drivers that's, you know, if it's outside of cost, which is an obvious one, that's, you know, substantially decreasing the payback?
Right. So with the conventional system, there's a need to drill and install those plastic pipes separately from any other infrastructure in the building. And so that's the main cost, sort of incremental cost for implementing a geothermal system. With the piles, what we're doing is we're integrating it directly into that steel foundation pile. So we're working with the existing steel foundation pile that's already going to be going into the ground to support the building and modifying it to circulate the working fluid within that pile itself. Another interesting property that we're going to be looking at, I touched on it with our control systems and what we're investigating here, is a larger fluid volume and thermal storage potential of the pile. So if you just bear with me here to explain a little bit, I've got a couple of graphs here. So in any geothermal system, there's a natural thermal storage within that working fluid. So when a geothermal system first turns on, it operates at a higher efficiency because you're first drawing on the heat stored within the working fluid before you start exchanging heat on a steady state basis with the ground. And so the chart here in the top left was a 24-hour lab test of a conventional geothermal U-bend and then the geothermal pile. And so the conventional system here, you see the spike at the beginning, which is a higher heat transfer rate when you first turn it on. And so you draw that heat in the fluid first, and then it starts exchanging heat with the ground on a steady state basis. With a pile, there's a much larger fluid volume in the system. And so that stored thermal energy effect is significantly larger. So rather than, you know, potentially 30 minutes here of higher performance, you potentially get several hours of higher performance through the pile because of that larger fluid volume. And so with this property, we can start looking at using the piles almost like a natural rechargeable thermal battery by actively letting it rest and naturally exchange heat with the ground. And that's this test here, which is another 24-hour test, which turned on a pile for 2 hours, let it rest, and then turned it on again. And so what we see in the shaded area here is that higher heat transfer rate during that period. So if we can start segmenting a pile array into, for example, 2 groups, we can start alternating them on and off and operating at a much higher efficient temperature range.
Yeah, that's okay. Thank you. That's a good answer. Yeah, I'll let the other guys go. I definitely have some follow-up questions for you for sure, though. Thank you for that.
Quick question for you. You said geothermal needs to be 300 to 600 feet. That's a pretty deep pile. Does that limit the number of applications? And then follow on to that, most of our buildings in Canada are floated, I'm thinking small buildings, houses, retail buildings, warehousing, that kind of thing. Is this more suited to large construction projects as opposed to, so those would be 2 of my questions.
Sure. So your first question there. So the typical wells that are 300 and 600 feet deep, they don't have to be that deep, but typically the conventional systems, they're working in they're usually drilling under the building footprint. So there's a space limitation. So they're usually going that deep because they've got to get the length to be able to get the capacity they need. There are horizontal systems out there that are only about 7 to 10 feet deep that lay the pipe horizontally, but they just need the space there. So once you get to a certain depth, about 30 feet is where it gets to a stable temperature. And then anything above that, you might be sort of less efficient, but you're still able to get that geothermal capacity. So the piles aren't going as deep, but what you see in these graphs here is that there's a larger surface area where the heat can exchange. So even though you're not going as deep, you're still getting a higher surface contact or unit depth. So you're able to get that heat transfer that's required. On your second question on sort of applicable buildings, yes, you're correct that it's got to be, or this system has to be with a pile foundation. So it's going to be applicable for buildings that's a viable foundation solution. So it's not going to be able to be in every type of building, but anywhere where there's a steel pile foundation that's viable, then the system could work there.
Okay, the 5-minute question and answer period is actually finished. So apologies to the other judges that didn't get to ask a question, but we'll have to move on now to be fair and have the next presentation start. So Andrew, thank you very much. And next we have Paul Berquist from Sky Foundry, who will be presenting the last pitch of the day. Okay, so let's begin. Sky Foundry.
Hello, everyone, and thank you to PropTech Summit and Uplift for the opportunity to present our technology to you today. My name is Paul Berquist. The name of our company is Sky Foundry, and the name of our software technology platform is SkySpark. SkySpark is software that automatically finds what matters in the data coming from your equipment systems and smart devices. One common term that is often used to describe our platform is the term analytics, but really is much more than just an analytics platform. The software contains all the functionality to collect, store, transform, analyze, and automatically present visualizations of the findings to users and operators. We often refer to that entire stack as automated informatics. So it's a complete end-to-end software application to better manage your built environment. So really what we do is create value from data. And the way we do that is to connect to the data coming from equipment systems in your building. We collect that data, store it, and then take the important next step, which is to use advanced computer science methodologies to perform automated analytics on your data. These analytics can detect patterns that might represent deviations from expected performance, an outright fault. And more importantly, the patterns can identify opportunities for savings and improved performance of your equipment systems. So the challenge is, while there's been dramatic advances in technology that make it possible to gain access to the data produced by a very wide range of sensors, systems, devices found in the built environment, and while access to that data opens up all kinds of new business opportunities for the creation of value-added services to help organizations reduce their energy consumption, costs, and identify opportunities to enhance operations, it turns out that access to the data is just the very first step in the journey, however. The real challenge is how to manage and derive value from the exploding amount of data produced by these smart devices and to find what matters in that data. And of course, to be able to do that in a highly scalable and cost-effective way. SkySpark by SkyFoundry was specifically built to address this challenge. The fully programmable software can be deployed on the hardware of your choice, from the edge to the cloud, and multiple SkySpark nodes can cluster together, allowing for highly flexible architectures to address real-world data and IT security needs. The company was founded by an experienced team who have built other highly successful companies focused on the built environment. Our founder is Brian Frank, who is the inventor and co-founder of the Niagara framework, co-founder of Tritium, which was a very successful company that's exited to Honeywell in 2005. Brian is also the primary contributor to key open source initiatives in the smart device realm, such as Obix, CoApp, Phantom, and Project Haystack. Co-founder John Petsy was formerly the CEO of Tritium and has held numerous other leadership roles in bringing new technologies and products to market in the buildings and energy efficiency space. Our business model is simple. We sell purely software. We sell to a channel of partners that implement solutions for facility owners. We have over 140 authorized system integrator and OEM channel partners worldwide. So that brings us to the point that SkySpark is a proven technology with a successful go-to-market business model. Our software has been deployed on well over 1 billion square feet in over 15,000 facilities on 6 continents, including Antarctica, all implemented by our extensive partner channel. In fact, the largest analytics projects in the world in the built environment utilize SkySpark. It is used in a variety of applications in the built environment, from smart homes to smart cities to smart intelligent buildings. We have numerous case studies across a wide range of verticals and market segments, all publicly available. A few are highlighted here. One of these case studies in particular, 1670 Broadway in Denver, utilized SkySpark's automated informatics and enabled the owners to achieve a savings of over $180,000 in annual operating costs. It also allowed them to increase their Energy Star score to 85, as well as assisted them in achieving LEED Gold O&M certification. So that's just a quick introduction to SkyFoundry and our SkySpark Analytics platform. We thank you very much for your time today, and I look forward to the questions from the panel.
It's a great presentation, Smart from PCL. If I was a building owner with 1 million square feet, a couple of questions. 1, how would I find you? 2, what would I need to implement solution? And 3, what would that look like for me on an annual cost basis?
So, you know, in terms of how would you find us, you know, we're fairly well known in the industry. We have partners in every major market in the world essentially right now. We do lots of trade shows and conferences where we're out promoting to end users and operators, the Realcomm event that just happened virtually, as well as many others throughout the year. So that's one way you could find us. In terms of what you would need to buy for 1 million square feet, the interesting about analytics as opposed to other types of technologies, for example, if you need a control system for 1 million square feet building, you kind of need a whole control system, right? Analytics you don't have to do analytics on everything in the building. You could start simply with analytics on your main electrical meters, right? And look for energy profiles where equipment's starting early, running late, running when it's not supposed to, and you can derive a tremendous amount of value from that. So analytics isn't necessarily a thing, right? So it would depend on how far you want to go with that scope and how far and how deep you want to go within your facility. Well, hopefully I addressed all 3 of those questions.
Yeah, I didn't really figure out how much it was going to cost me on an annual basis though, Paul.
Well, yeah, sorry, to reiterate that point, you could be monitoring just an energy meter, right? So our software scales from a small, we sell it based on capacity, as little as 10 points, all the way up to millions of points that's deployed across campuses. A 10-point license, if you just want to monitor your energy meters, is $60 for the entire software stack that you can install on a very low-cost computer.
So it's not on a square footage basis. It's based on the number of endpoints that I would want to license in my building, which could be 1 or could be 100,000.
That's correct.
Okay, thanks, Paul.
Sorry, it wasn't more clear.
Okay, does someone else want to jump in from the judging panel?
Sure. It's Adrian here from Tradell.
Hi.
How is this different from other building automation systems out there, like Siemens, for example?
So, it does far more than just building automation system, right? A building automation is taking in data locally. Typically, it's aware of whatever sensors are connected to that particular controller or network of controllers. Oftentimes, that doesn't take into account data coming in from other sources, whether that be weather data. Very difficult to get data from a smart meter that's sending its data out to the internet, to a cloud service, back into a building automation system. So it's typically only an automation system is running local control loops that's evaluating the sensors that are directly tied to it. SkySpark's able to take in data from all kinds of sources, whether it's data over web services feeds, weather data, building automation data, and look for patterns in that data over time, right? Typically, a fault in a building automation system is going to look for, hey, this sensor is above this threshold. Well, with analytics, you can say, your energy meter was over a threshold. We deviated by this much. It happened this many times in the month, and it can automatically calculate the total cost of that fault across a wide period of time and take into account multiple data points versus just a high and low limit on a particular sensor.
Okay. Does anyone else from the judging panel have questions for Paul?
Yeah, I'll ask you one more, Paul.
Sure.
Do you have an open API model in your software, and does your software effectively enable a digital twin in the build space?
Yes, the answer is yes. We have an open API. It's a REST style API. It's built on top of the open source Project Haystack REST API, and it is used in that manner to enable digital twin technology. Yeah.
Okay.
Sounds like you've been around for quite a long time. What's next for your organization in terms of future innovations?
Future innovations, we're just getting ready to deploy an application that allows you to track, you could consider them notes or tickets or documents on particular events. An event happened in a particular facility, and an end user operator saw this thing and did some exploration, can attach a ticket to it. And it can work in a cluster of nodes. So an individual user in a building who assigns this ticket, it rolls up to the entire cluster, but can be tracked across the organization, integrate with other tools like maintenance management packages and real estate reporting packages in the ERP, CRM. So that's the next big thing we're getting ready to delve into in terms of the market strategy.
Thank you.
So the time is up for the question and answer period. So I'd like to thank you for your presentation, Paul, and kindly stop sharing your screen. Thank you. And so we can bring everybody back, and we're going to be wrapping the session up. So it was an absolute pleasure to moderate this session and to hear about those wonderful innovations. The pitches were excellent, and the solutions we heard about today cover some of the most important and topical areas in IoT and PropTech. I'd like to thank our judges for their insights and questions. And I'm sure you all have many more. So we will get you in touch with the people that you'd like to speak to further. But before we wrap up, I'd just like to ask the judges if you have any sort of final comments to wrap up. Any comments about the pitches in general, and any comments for the specific innovators? We have a few minutes left for that.
I can weigh in a little bit. I'm kind of I see lots of these. What I would say they're all very good. To me, this would just be advice, and it depends on the stage of your business, who your audience is, whether it's VC, whether it's what series you're in terms of funding. But what I personally always find, and you can't do this in 5 minutes, so I'm not suggesting that I would recommend a change to your 5-minute presentation, because that's really tough. I don't know that I could have done our presentation in 5 minutes. So very good job there. What I will say that I always find in some of the decks that I look at and things like that is really try and showcase the kind of the execution component of what you're going to deliver on as a business. you see in the markets, it's forecasting's easy. Anybody can forecast, anybody can tell the story. But in terms of, when making an investment, and again, it depends on the stage and who your audience is, but really getting a clear understanding of how you're going to execute, stability where you are today around being able to do that. I always find that when I'm, with our business too, we raise capital as well. And, one of the most favorable comments that I get on that is, clearly articulating how you're going to make this come to life in a plausible way that isn't egregious in terms of, massive hypothesis of what you're going to put together. So not that you could do that in 5 minutes, but I just thought I'd share that bit of experience on my end.
Very good advice. Thank you for that, Travis. And any of the other judges have any final wrap-up comments?
Sure, I'll chime in. Good presentations, guys. Keep pushing the envelope. Anchoring a little bit on Travis's advice. Try to find and establish. I always have a crawl, walk, run mentality. So when you're incubating a new product, make sure there's an absolute need in the market. Understand what the client needs are, how you can incubate it, perfect it, and grow it. That's everyone's challenge when you start a new product, certainly. And looks like you guys got some interesting technology to apply, primarily around sustainability, which is certainly a hot button in the world economy today. So I wish you guys the best of luck going forward. Thanks a lot.
Yeah, great concepts. It's interesting. We're seeing sort of a real cross section here as well, from a very early stage to a proof of concept stage to a more mature stage. So interesting to see that cross section of
yeah, I found that interesting too, for sure.
And another aspect that was quite interesting is that some of these technologies are really impressive. And, if I can give one piece of advice, because, at Microsoft, we get to see some of the most incredible startups that have really good ideas. And the ones that usually get to a go-to-markets are the ones not necessarily that have the best technology, but have really thought through their business plan in terms of their target market. And like Mark said, the crawl, walk, run approach is not a bad one to take, because there's so many different areas that you can spin off in terms of ideas. And when you have really bright, smart people in technology, it's hard to have that focus. So, bring the focus into what you're trying to achieve, find that target market, and start small.
Yeah, great comments by all the panelists and all the judges. I think the pitches were terrific. I think Travis hit it home with his point about, just being able to carry through its execution. It's not always about the best technology, but how you execute and how you're able to pull it all together in a business plan, and finding a business case that makes sense for the end user, right? And putting yourself in the shoe of the consumer, understanding what their pain points are, or your client, and figure out the solution that identifies most with them, and a pricing strategy that makes sense as well. So great presentations.
Very good. Thank you very much to the judges for your excellent comments, and to the innovators for your excellent pitches. Thank you very much all for your insights, which I think I'm sure were very helpful for the innovators, and good luck to all of the companies that presented today. You're doing great work, and we wish you all the success in the world. A reminder that the winning team will be announced later today at the end of the event. So we'll look forward to hearing about that later. And thank you to everyone who joined us today. If you're also an innovator or would like to reach one of the innovators, one of the innovator teams that presented today, please connect with us through our social media or websites. Good afternoon. Thank you.
Thank you.
Thanks a lot.